Okay, so on this first problem, rewrite and simplify if possible. This is where a lot of people make a mistake. Notice that this 2/5 only goes to what it's touching. Therefore, your answer will be 20. Remember, bottom is your root, top is your power or exponent. So this will end up being 20, and then the 5th root of x squared. You could write the 5th root of x in parentheses. You could have it like this, 20, 5th root of x squared. That also works. It will look like this on your test, though, without the parentheses. Okay? I can't simplify it because the 5th root of x squared, you need 5 x's. I only have 2. So it can't simplify. That's my answer. Negative exponents. You can't have them. How do I get rid of a negative exponent? Change sides. Okay, so I take this negative exponent is touching the 81. I move that thing to the bottom. So now I have 81 to the 3/4 power. If nothing's on top, you put a 1 there. Change this to root form. So that will be the 4th root of 81 cubed. 81 breaks down to 9 and 9, which is 3 and 3, 3 and 3. So there are 4 3s. Okay, so that means we end up getting 3 to the 3rd power. And what is 3 to the 3rd power? So 1 over 27. Not 27, but 1 over 27. Make sure you write your answers correctly. Okay, questions on 2. Okay, is it okay to have a negative number? Yes, we just can't have a negative exponent. Good. So when you have a 1/3 power, that means that you are taking the cubed root of negative 1 over 27, which is really the same thing as the cubed root of 1 over the cubed root of negative 27. And the negative could go either place. What is the cubed root of 1? 1. What is the cubed root of negative 27? Negative 3. This is 9 and 3, 3 and 3. Remember that whenever you have a negative under an odd root, the negative just comes out. So that's negative 3. So there's my answer, negative 1/3. Questions? Okay, number 4. Notice that these both have base 5s. If these numbers are the same, all you have to do is add your exponents. But in order to add my exponents there, they need to have a common denominator. Okay? What would be the common denominator in this case? 6. So if I'm taking 1/2 plus 2/3, I want them to have a common denominator of 6. So for 2, I need to multiply 2 times what to make 6? 3. So 1 times 3 makes 3. Over here, 3 times 2 makes 6, so 2 times 2 is 4. And we add those together and we get 7/6. So that means my answer is 5 to the 7/6 power. Any questions there? Yes?
Can we also write it as the sixth root of 5 to the power?
You could, yes. But the multiple choice answer will look like this. Okay, but if you changed it, you would see that both of them are there. Or that one there. Okay, other questions?
So the 5 substitutes?
No, because when you're multiplying, just like if I had like x squared times x to the 3rd, we keep the x and then you add 2 plus 3 and get 5. So it's the same thing here. We're keeping the 5 and we're adding them.
On number 7 for range, does it matter if they put X or Y?
Just change it if it's wrong. Okay, number 5. This 4th root means you're taking the 4th root of 1 over the 4th root of 243. What is the 4th root of 1? 1. 243 breaks down. Okay, this is 81 times 3. 81 is 9 and 9, which makes 3, 3, and another 3, 3. So how many do I need for a group? So I have 4 3s, but I have a 3 left over. So when I write this, this is 1 over 3, 4th root of 3. Can I have a root in the denominator? No. How many more 3s do I need? 3 more. So I'm going to multiply by the 4th root of 3 times 3 times 3 because that makes a total of 4 when I multiply them all together. But whatever I do at the bottom, I also have to do to the top. Okay, so I have another group of 3's. So that means my denominator is what? 9. Because I already had this 3 outside. When I bring out that group, I'm going to multiply it to the other 3, which makes 9. And then on the top, we just have the 4th root of 27. Because 3 times 3 is 9. And then 9 times 3 is 27. Okay, questions on 5. Number 6. We are trying to get x by itself. How do I get rid of that 3 over 2 power? Raise it to reciprocal power, which would be to the 2/3. Okay, that cancels all that out. We get x equals, and here, this, we're going to change it. It's going to be the cubed root of negative 125 squared. Well, negative 125 is 25 and 5, and 25 is 5 and 5. So we have 3 5s. So that makes what? Good. Negative 5 squared, which is 25. Questions on 6. Seven, is x by itself?
No.
What do I do to get x by itself? Divide by 3. What is 81 divided by 3? Good. Am I good now? How do I get rid of the 3/4? Good. Raise it to the reciprocal power, which is 4/3. That cancels that out to get x by itself. We rewrite this as the cubed root of 27 to the 4th power. 27 breaks down to 9 and 3, which is 3 and 3. We have a group of 3's. So we have 3 to the 4th power, which is 81. Okay, number 8. For what value of x does the expression, the 5th root of x to the 5th, represent a real number? Anytime you have an odd root, you can have positives or negatives inside here and get a real number. So the answer is all reals. So if you have an odd root, your answer will be all reals. Okay? If you have an even root, like if you had the 4th root of x to the 4th, this would be all non-negative numbers. Even roots, no negative numbers. Can you have 0? Yes, 0 is okay. Negative numbers, not okay. So that's why it says all non-negative numbers, because 0 would be considered not a negative number. Are we good there? All right, number 9. It says, which of the following conclusions is true about this statement below? First of all, x squared minus 36 factors to be x minus 6, x plus 6. If I take the square root of x minus 6, x plus 6, do I end up getting x minus 6? No, because these are not the same. If I had x minus 6 and x minus 6, then I could get x minus 6, okay? So check these. Check to see if any of them make a true statement. If you plug 0 in here, you'd end up getting negative 30, the square root of negative 36. Can you take the square root of a negative number? No, A won't work. If you plug 6 in here, 6 squared is 36. 36 minus 36 is 0. Can you take the square root of 0? Yeah, it's just 0. And then is 6 minus 6 0? So it looks like B works. We know it's not always true because 0 didn't work. And we know it's not never true because 6 worked. So therefore, B is the answer. Okay? Yes? Okay, 10. Which of the following is not a function? You check things, if they're functions, by the vertical line test. If I were to graph A, okay, the graph of A is at y equals 5. Okay, so you got 1, 2, 3, 4, 5. This would be your graph. Is that a function? Yes, because if you did the vertical line test, it would be a function. Okay, so this one is true. It's a function, okay? X equals negative 2, B. Okay, negative 2, line up and down. Does this pass a vertical line test? No, it does not. So I'm thinking B is my answer. This right here, C, it is a Parabola. Do parabolas pass the vertical line test? Yes. D is a line. It would look like this. Do lines pass the vertical line test? Yes. The only one that did not pass the vertical line test was D. Anytime you have x squared, it's a parabola. With x squared with a plane y, it's a parabola. When you have plane x and y, it's a line. Anytime you have x equals a number, that's not going to be a function because you won't pass the vertical line test. Y equals is okay. All right, 11. It says find f of x times g of x. So my f of x is 8x to the 1/3 power times g of x is 27x to the 2/3. Pay attention to what your exponents are touching. On this first one, the 1/3 is touching the parenthesis, which means that the 1/3 is going to the 8 and to the x. So then write this as 8 to the 1/3, x to the 1/3 times 27x to the 2/3. 8 to the 1/3, how would you rewrite that? The cubed root of 8. What is the cubed root of 8? 2. Okay? Because this is 2, 2, and 2. Okay? So I end up getting 2x to the 1/3 times 27x to the 2/3. Numbers and numbers you can multiply. So 2 times 27 is 54. And then since I have an x space and another x space, I add their exponents. Do they already have common denominators? Yes. So 1/3 plus 2/3 makes what? 3/3, which reduces to 1. So you would have x to the first, which is really just x. So that's how we get 54x for our answer. Questions there? 12, it's asking for the domain. Remember, under square roots, I'm going to put under roots, no negatives. Okay? When you have an even root, you do not want any negatives underneath here. So your domain can only be values that will make 0 or positive. So we talked about how you would take x plus 6 equals 0, because 0 is okay, and we get x equals negative 6. So if we had negative 6 here, we'd get 0, which is fine. I can get that. Anything bigger than negative 6 would also work. So my domain is x is greater than or equal to negative 6. Because any value that is negative 6 or bigger will make positive numbers. Because if you have negative 5 here, it'll make a positive 1. If you have 0, you get 6. All numbers that are bigger than negative 6 will give me a positive under the root. If it was smaller than negative 6, like negative 7, it would give me a negative, which would not be a real number, and it would not work. Are we okay with 12? Okay, when you are dealing with fractions, okay, fractions, you cannot have a 0 in the denominator. Okay, so that's the one thing you have to be careful about with fractions and domain. Is there any value that I could give x that would end up making a 0 in the denominator here? The denominator here is always going to be what? 5. There's no way of changing that. There's no variable here where you could plug in a value and it would change the denominator. So this one is just all real numbers. Okay? Now, a separate question that I made if you looked at my answer key is that if you had a problem like 5 over x plus 2, okay? Okay? Well, on this one, is there a value that can make 0 in the denominator? Yes. So this answer for this problem would be all reals except x cannot equal what? Negative 2. Do you notice the difference between these problems? Yes? Okay, we're good? All right, moving on. Okay, 14. They give you f of x and they ask you to find f of 3x plus 2. So this means we're going to my f equation and I'm taking this and plugging it in for x. So we're going to write this as 4 times 3x plus 2 plus 3. And all we're doing is simplifying. Are we okay with what I've done? So we distribute. We get 12x plus 8 plus 3. And when we simplify, we get 12x plus 11. That's your answer. Questions on 14. Okay, 15. They give me my f of x equation, my g of x equation, and they say find f of g of x. What do we do first on this problem? Very good. We find g of x. We always go with the innermost parentheses. Well, g of x means we're going to plug x in wherever I see x here. So what's my answer for g of x? 3x plus 2. So this goes away, and now I'm finding f of 3x plus 2, because g of x, this answer right here, is just 3x plus 2, right? So now we are finding f of 3x plus 2. So that means I'm going to my f equation and plugging in 3x plus 2. So we have 3x plus 2 squared plus 5. Because 3x plus 2 went in that spot. For this one, you're going to have to FOIL or use your box. That one is difficult to do in your head because of the 3 in front. And so we'll just write it out to make sure we do it correctly. Although I'm sure some of you would be fine. All right, so we end up getting 9x squared, 6x, 6x, and 4. So this makes 9x squared plus 12x plus 4, and then we still have plus 5. And then we simplify and get 9x squared plus 12x plus 9. And that's your answer. Questions on 15? Okay, 16. What am I going to start with first? Find your g of -3. So we go to our g equation and we're plugging in -3 for x. So that means I have 5 minus -3 squared. Be careful here. We always square first, right? Do not make these two negatives a positive. What is -3 squared? So that means I have 5 minus 9. And what is 5 minus 9? -4. So that means that this g of -3 actually is what? -4. So now we're finding f of -4. So I go to my f equation over here and I'm plugging in -4 for x. So we have 2 times -4 plus 7. -8 plus 7 makes -1. So my answer is -1. Questions on 16? Okay, 17. Again, we have an f of x and g of x, and we're adding them together. So my f of x is this right here, x squared plus 3x plus 3. And my g of x is this, which is plus 2 times x minus 1 squared. What will I do first in this problem? Your exponent, right? So you're going to do your box or FOIL. And when you do that, I end up with x squared minus 2x plus 1. Okay, and I still have all this other stuff. X squared plus 3x plus 3 plus that. What will I do now? Distribute. Very good. So we get 2x squared minus 4x plus 2. And then again, I still have all this other stuff. And lastly, we will combine our like terms. So x squared and 2x squared makes 3x squared. That part's done. We have a 3x and a -4x, which makes a -x. And then we have a plus 3 and a plus 2, which makes a plus 5. Questions there? Okay, 18. When you're finding the inverse, what are we doing? Exchanging x and y. So this really is y. So if we exchange x and y, when I rewrite this, I write this as x equals 2y minus 1 all over 7. Do we like fractions? No. So what am I going to do? Multiply by the reciprocal. So I multiply by 7 over here and 7 over here. Okay, you're actually multiplying by the common denominator if you want to think of it that way too. So those cancel out. And 7 times x is, so I have 7x equals 2y minus 1. We want to get y by itself, so what will I do now? Good, add 1 to both sides. We get 7x plus 1 equals 2y. And what would be your next step? Very good, divide by 2. Okay, so you end up, and remember your answer, y to the negative 1, you want to have that negative 1 exponent, equals 7x plus 1 all over 2. Since your original equation was f of x, you could also, or if it's multiple choice, your answer would be f to the negative 1 of x. But either is okay. Questions on 18. Okay, 19, what am I going to do? Same thing, exchange x and y. This is y equals, okay? So we have x equals 4y minus 1. We want to get y by itself. So I add 1 to both sides. We have x plus 1 equals 4y. And your last step would be to divide by 4. Okay, so now we have y by itself. On this one, I'm just going to write my answer as f to the negative 1 of x, because that was how my original equation was, equals x plus 1 all over 4. And that is my answer. Questions there? Okay, moving on, number 20. Again, we are finding the inverse. This is one of the most missed problems on the test, so pay attention. Focus, okay? Remember that this is actually y. To find the inverse, what will I do? Exchange x and y. So we're going to write this as x equals negative 125 over 8 y to the 3rd power. Do we like fractions? So you could multiply by the reciprocal if you want to. I'm just going to do it this way right now. I'm just going to multiply both sides by 8 to get rid of the fractions. When I do that, the 8's cancel out, and we get 8x equals negative 125y cubed. What would I do next here? Good. Divide by negative 125 to both sides. So now I have 8x over negative 125 equals y cubed. Now what will I do? To get y by itself, you're going to take the cubed root. And I'm going to do this where I'm taking the cubed root of everything like that. Can I take the cubed root of 8? Yeah, it becomes 2. Okay? So we get 2. Can I take the cubed root of x? No. So I have to write that as the cubed root of x. I could bring out the 2, but I have to leave the x. And what is the cubed root of negative 125? Negative 5. Good, because that becomes 25 and 5 and 5 and 5. And because there's a negative, it's negative 5. And that's it. That's your answer. So you have f to the negative 1 of x equals 2 cubed root of x all over negative 5. And whenever you have like something on the top, like an x on the top, it can be on the top or they could kind of pull it to the side. So I think on your answers, they kind of pull it to the side. Are we good with 20? Okay, 21. What's my issue with 21? Root in the bottom. How do I get rid of the root in the bottom? Good. We need 2 more 2's, right? Because I need a total of 3 2's. Whatever I do to the bottom, I also have to do to the top. So now I have a total of 3 2's. So that means my denominator is 2. And on top, I have 5x. I can't pull anything out there, so that's just going to be the cubed root of 4. If you could reduce the 2 and like the 5, if there was a number outside that you could reduce them with, you would, but you can't, so that's your answer. Questions? Okay, 22. We need to get the square by itself, or the square root by itself. So to do that, the first thing is I add 1 to both sides. I have 3 square root of x plus 2 equals 9. Next step, we divide by 3 to both sides. Square root of x plus 2 equals 3. We want to get rid of the root, so I square both sides. We get x plus 2 equals 9, and your last step would be to subtract 2. And we get x equals 7. Okay, 23, this is another most missed question. My square root's by itself, so I square both sides. This is where people mess up though. Okay, when I square this side, I get 3x plus 12. When I square this side, what do I get? 9x. A lot of people write it as 3x, which is wrong. You have to square the 3. It's not under the root. So you get 9, and when you square the root x, you get x. Then to solve now, we subtract 3x to both sides. 12 equals 6x. Divide by 6 to both sides, and x equals 2. Okay, 24. Is the square root by itself?
Yes.
Yes. I square both sides. So I get 44 minus 2x equals, and I have to box or FOIL this, which will end up making x squared minus 20x plus 100. Since we have an x squared term, we want to factor or use your diamond method, so we want this set equal to 0. I'm going to subtract 44 and add 2x to both sides. These cancel. I get x squared minus 18x plus 56 equals 0. When you do your diamond method and factor this, you end up getting what numbers work? What multiplies to be 56 and adds to be negative 18? Good. Minus 14 and x minus 4. And when I set those equal to 0, x equals 14 and x equals 4. Now remember, when we factor, you always want to check those answers. This checking is kind of easy because if I take this x equals 4 and plug it in here, when you put 4 minus 10, what do you get? Can we take a square root and end up getting a negative 6? No, that will not work. So my answer is only 14. Okay, trying to go fast here. Okay, 25. We need to know domain, range, and if it's a function. Looking at it really quick, is this a function when you do the vertical line test? Yes. Okay, ordered pairs. This ordered pair way over here is at negative 6, negative 2. I would recommend writing each of the points down and then doing domain and range. Okay, this ordered pair is negative 4, 1. This one right here is at 3, 2, and this one is at 4, negative 1. Remember that your domain is always your x values and your range is always your y. So for my domain here, it is at negative 6, negative 4, 3, and 4. Remember, points have specific values when you're writing your domain and range. My specific range values are negative 2, 1, 2, and negative 1. And that's it. Okay, are we good with 25? Okay, 26. This is a line, so remember this is continuous, which we're going to use our less than or equal to signs. First of all, is this one a function, yes or no? If you did your vertical line test, yes, nothing overlaps and hits a point twice on the graph. My domain is x, range is y's. If we're looking at our x values, what is my smallest x value here? 0 is less than or equal to x is less than or equal to 6. On your range, so I'm going up and down now. My range is my y and my domain was my x. My smallest one is 0, is less than or equal to y, is less than or equal to, and my largest range is at 3. Are we good with 26?
Yes.
Okay, 27. It wants us to find the g of f of 7. We start with our innermost parentheses. F of 7, I go to my f equation. 2 times 7 plus 5. 2 times 7 is 14. 14 plus 5 is 19. So this goes away, and now I'm finding g of 19. So I go to my g problem, and I'm plugging in 19. 2 times 19 plus 7 divided by 3. 2 times 19 is 38 plus 7 divided by 3, which makes 45 divided by 3, and that reduces to 15. Questions? All right, and 28, when I'm finding the inverse, what am I doing? It's changing x and y values. So this is x equals negative 1/5 y plus 2/5. Do we like fractions? No. Multiply by your common denominator, which would be? 5. Multiply 5 to every single term. The whole purpose is to get rid of fractions. I end up getting 5x equals, here the 5's cancel, and you have negative y. Here the 5's cancel, and we have plus 2. We want y by itself. Good. Subtract 2 to both sides. 5x minus 2 equals negative y. Is that good? No. We need to divide by to every single term. So we end up getting negative 5x plus 2 equals y. But when we write our answer up here, what do we write it as? Y to the negative 1 equals negative 5x plus 2. And that is your answer. Questions?